Okay, in this next part, we're going to find some exact trig values as we go around the circle. Now, in this part, I'm going to stray a little bit from how the book is presenting it, and by all means, you're welcome to go check out the book and read through that section. They take more of an algebraic approach versus the geometric approach, but either way you go, it takes a little bit more geometry than what we're covering in this class. You've got to go back and either remember special triangles or remember chords and arc length. So I think that the special triangles are a little bit easier to follow for this part. But again, you're welcome to go look at how the book represents it and do it that way as well. So to do this in terms of special triangles, actually I'm going to have to make that a little bit bigger. So you have to remember two special triangles, and one is the 45, 45, 90. Okay, so this is in terms of degrees, 45, 45, 90. And that says if you have the two legs, that the hypotenuse, you multiply by the square root of 2 to get to the hypotenuse. So if it's 45, 45, 90, it's got to be isosceles. Okay, the two angles match, so the two sides have to match. And then to get the third side, you can use the Pythagorean theorem, 1 squared plus 1 squared is 2. And so that side has to be the square root of 2. All right, so that's our 45, 45, 90. And then we've also got our 30, 60, 90, which kind of looks like this. So 30, 60, 90. And then for that one, you've got, let's see if the make sure I get this right. Okay, so the short side would be 1/2. The hypotenuse would be 1, and then the long side would be square root of 3 over 2. Okay, so going from the short side, you would double it to get to the hypotenuse, and you would multiply by square root of 3 to get the other long leg. Okay, so we're going to use these special triangles to fill in some values as we go around the unit circle. All right, now we know that this is 0, okay, and this is pi over 2, or in other words, 90 degrees. If we cut that in half, right here, we would have pi over 4, which we know is the same as 45 degrees, because this is half of 90. Okay, so pi over 4 would be the same as 45 degrees. We can do that without having to do any unit conversions. All right, now if we made a triangle in here, okay, make a triangle up to here, down like that, we can see that there's our 45, 45, 90. Okay, but the difference here is that the radius is 1. Okay, so in order to get these two sides, now instead of having this exact triangle, what we actually have is we have that the radius is 1. So how do we get these two sides? Well, you would divide by the square root of 2. So if you're going this way, you multiply by the square root of 2. If you're going this way, you divide by the square root of 2. So we are going to divide by the square root of 2, like that. Now in this class, we don't like to leave square roots on the bottom, so we're going to rationalize the denominator. And to do that, we multiply by the square root. So we get square root of 2 over, and then square root of 2 times square root of 2 would just be 2. Okay, so this side is square root of 2, square root of 2 over 2, and this side would also have to be square root of 2 over 2. Okay, so coming back up to here, this side is square root of 2 over 2, this side is square root of 2 over 2, so that means that our point is square root of 2 over 2, and square root of 2 over 2. Our x distance and our y distance are the same, and we know that the value is square root of 2 over 2. Okay, so that gives us one exact point that we know happens at pi over 4. All right, let's see if we can do two other ones. So we should be able to do right here, this would be pi over 6. And this would be pi over 3. Alright, now if you do the unit conversions for these, pi over 6 is equal to 30 degrees, and pi over 3 is equal to 60 degrees. So what we're looking at here are the 30, 60, 90 triangles just sitting in two different positions. Okay, so if we do this one, oops, let's try to make that a different color. Here we go. Okay, let's look at the pi over 6 one. We've got that blue triangle. Okay, so this is the triangle that we're looking at. Here's the right angle. And we know that the radius is 1. That's the hypotenuse right here. Okay, so this looks exactly like our setup here. The short side is going to be 1/2. The long side is going to be square root of 3 over 2. Okay, so how do we set up our point for this one? All right, we see the long distance, that's our x distance. We go over square root of 3 over 2, and we go up 1/2. Okay, so over square root of 3 over 2, up 1/2. All right, now square pi over 3, it's going to be the same triangle, it's just sitting in a different position. Oh, let's do a different color. Let's do purple. Okay, so this one's sitting like this, like that. Okay, so same triangle, but a different position. So the hypotenuse right here is our radius, that's 1. And we've got short side, long side. So again, it's the same triangle, just sitting in a different position. So short side is right here, 1/2. Long side is square root of 3 over 2. Okay, so how do we set up our point? We go over 1/2, and we go up square root of 3 over 2. Okay, so all of these values came off of these two special triangles. You don't really have to have those memorized, but I think it helps you see where all these crazy numbers come from, because otherwise it would be really hard to make sense of that. Okay, now let me clean this up just a little bit. Okay, so I cleaned this up a little bit just so we can see the numbers a little bit better, and then we can, so if you can get this first quadrant right here, you can get the values all the way around the unit circle, and we'll finish this off in class, but just to give you an idea of what it looks like. Okay, so for example, here's pi over 4. The next one over here, if we count pi over 4, another pi over 4 would give us 2 pi over 4, that'd be right here. Another pi over 4 would give us 3 pi over 4, and that would be right here. Okay, so here's pi over 4, here's 3 pi over 4. It's the exact same geometry over here. It's the exact same triangle. The only difference is that our x is negative and our y is positive. So x is negative, y is positive, but otherwise it's the same exact triangle. So over here you would have this same point, but you'd have negative square root of 2 over 2, positive square root of 2 over 2. Okay, and then if you go that multiple around here, it's the same triangle, but it's negative, negative. And then over here, it's the same triangle, but it's positive, negative. Okay, so all of these points as you go around give you the same triangles. You just have to figure out which one's positive and which one's negative. So for example, let's say this one right here. Okay, so we've got, oh shoot, I drew these in wrong when I came back and drew these in. Sorry, I just caught it just now. Let's redraw those. Pretty sure I had them right the first time, but when I came back and redraw them, I did them wrong. This one's pi over 6, this one's pi over 4, and this one's pi over 3. Okay, so this one's pi over 6. Another pi over 6 would give us 2 pi over 6. Another pi over 6 would give us 3 pi over 6. And another pi over 6 would give us 4 pi over 6, which is the same as 2 pi over 3. Okay, and then another pi over 6 would give us 5 pi over 6. And then another pi over 6 would give us 6 pi over 6. It would be right here at pi. Okay, so we're counting by multiples. These are by multiples of 4, and these are by multiples of sixths. Alright, and then we can see that here, this triangle, this tall skinny triangle would be the same as this tall skinny triangle. The difference is that the x value is negative. Okay, so see, same thing. And then over here, this long flat triangle is the same as this long flat triangle, but it's negative. Okay, and then we can continue that all the way around. So we'll go ahead and finish this off in class, but this is how you get started on the unit circle and filling in all of those different values.